Hey there, in this video, you're going to learn how to set up a relational data structure using Power BI and Power Query. This is a really important skill set for anybody who wants to work with data professionally, especially on the data analyst, data engineer, data scientist side. You'll hear from Aaron Parry, our Power BI instructor at Maven Analytics. He'll make this stuff look pretty easy. Hopefully you'll get a chance to practice and commit these skills to your daily workflow. Hope you'll enjoy the video.
So the purpose of the session, right, we're going to cover the fundamentals of how to normalize a wide merged table into a multi-dimensional model in Power BI, really using Power Query. So if you're an Excel user and you're using Power Query in Excel or Power BI, again, the process is going to be very, very similar. So let's jump into the slides a little bit. Really just want to use these to help illustrate some of the points and the concepts that we're going to be covering using Power Query today. Little bit of the agenda today. We're going to we'll start with a problem definition, right? Why flattening everything into one table is really inefficient. Certainly different use cases when this might be beneficial, but generally speaking, within Power BI, this leads to a very inefficient and bloated model. So we're going to talk about some of the database normalization basics. We'll talk about the kind of best design, if you will, a little bit of foreshadowing there, this star schema, and we'll talk some about the fundamentals there. We're going to talk about creating dimension and fact tables in Power Query. So part of the demo, we'll actually walk through how to take that wide merged table and break it down into its component kind of fact and dimension table. We'll build our relationships in the data model. Depending on how we're doing for time, we'll cover some advanced normalization topics. So we'll address first normal form, but again, depending on time, we'll get into second and third normal forms for normalized models. And then finally, we'll kind of wrap up with some key takeaways. Awesome. So that problem definition. Merged tables, right? Merged tables are these single flattened tables, and because of that, they tend to have a lot of redundant data, right? There's duplicate records, and it often requires a lot more memory and processing power just to handle the size of this table. So again, these merged tables, they're not great because they contain that redundant, repeated data. Based on large file sizes, there tends to be performance issues as these data sets grow in size. You have some scalability challenges. So if you've ever tried to update a really large merged table, you'll probably notice that it loads or updates very, very slowly. And then again, you're prone to errors here. So again, when you've got these repeating redundant values, you're trying to add in new records, you're just really opening yourself up to potential errors. So a lot of reasons here why those merged tables aren't great though. So that's kind of the problem statement. So to take care of that, we want to go through this whole process of normalization, right? And what that is it's really this process of organizing the tables and columns in a data set to preserve integrity and to eliminate redundancy, right? So those are the kind of two main purposes for going through and normalizing a model. So let's take our example merged table here, right? We've got this really wide table. We've got some transaction-related data in gray. We've got customer-related data in blue. We have store-related data in yellow, and then this product-related data in green. And depending on how rich this data set is or how many features are here, you're going to have a lot of columns for each one of these sections. You could potentially even have more sections, depending on the granularity, of that merged table. So in order to kind of start thinking about the process of normalizing it, you really want to think about how do you start to pull each of these kind of attributes or these, lookup tables, if you will, out of this merged table into their own unique, kind of tables. So the process is something like thinking about, okay, I've got customers. I've got all of these attributes associated with customers. I've got a store level table, right? I've got a product level table. And each of these lookup tables, right, they end up containing, all of these other columns, right? And then they're associated by IDs, right? Between these lookup and the fact table. So what that allows you to do once you start creating those lookup tables is to remove those redundant columns within your merged table, right? Within that fact table. And then you can start building relationships between the lookup and the dimension, and the fact table, right? So we're going to tie between our ID columns between those two tables, right? So these are those primary and foreign key relationships between the lookup and the fact table. So when you go through this process, right, this helps to eliminate redundant data and it decreases the table size. It helps improve your performance and scalability, right? Each table serves a very distinct and unique purpose in this type of a setup, right? So it really helps with that performance and scalability. It simplifies the queries and the structure of the data set, and that really helps for a more meaningful, intuitive analysis. We'll kind of talk about this, in a little bit more detail. But again, when you're creating a data model in a tool, like Power BI, or even in Excel and the data model features there, creating a very simple, intuitive structure is really what's going to help you write better DAX, create better visuals, create better pivots, that kind of stuff, and really promotes that meaningful analysis. And kind of finally here, this normalization process helps you minimize errors and anomalies from any sort of data modifications. So thinking about these tables, right, we kind of have this central fact table, right? This has our transaction columns. We have our customer ID, our store ID, and our product ID as our foreign keys within this table. Oh, wrong way. And then when you start creating your relationships, right, we tie our customer ID to customer ID, store ID to store ID, product ID to product ID. And what ends up happening is you end up creating this star schema pattern, right? You have this central fact table that is surrounded by these different lookup tables. And generally speaking, this is the most optimized way to create a data model within Power BI. Awesome. So we're going to jump out of the slides. We're going to go into Power BI for a moment here. But that is basically the context, right, for the demo that we're going to work through. Awesome. So we can make this data set available, after the session here for anybody who wants to run through this themselves. But I'm going to go through, I'm going to import my Excel file. I've got this transactions data. And we'll do a little preview of the data here. And you can see, again, this demo or this data set is built, purpose built for this demo. It's set up, in a pretty clean way, to make sure that we can, touch on each of these topics in a meaningful way. But if we look at the columns, we kind of start off with that transaction related data. We have some customer data starting with customer ID. Keep scrolling over with store ID and some store related data. We've got product ID and product related data. So let's click transform data. This is going to bring us into the back end of Power BI and to Power Query, where we load the entire table. So I know we said that we were going to kind of talk about the normal forms a little bit. Right now, this table is in something that's called first normal form, right? And that's because each record in each field is atomic. Right? And what that really means is that each cell in the data set contains one single data point, and there's no sorts of lists or repeated groups within a single record. So when we start, depending on how we're doing for time later, when we get into some of the other normal forms, this is first normal form. So what we want to do is, if you, again, kind of visualize the slide layout, we have this single merged table, and we need to start creating those lookup tables based on this merged table. So if we right click, we want to duplicate this table 3 times. And what this is going to allow us to do is create the different lookup tables based off of that base, transactions table. So first things first, let's create our customer lookup. So for our customer lookup, let's scroll over here. We have customer ID. And we're going to scroll all the way over until we get to customer date of birth. These are all of our customer related columns. Again, depending on how familiar you are with Power Query, there's a lot of different ways that you can access, tools, menu options, features. But what we want to do is we want to remove all of the other columns. We only want to keep our customer related columns. So if I right click and select remove other columns, that creates a nice table that only has our customer attributes. The next thing that we want to do is, because this is going to be a lookup table, right? We need to have a good primary key, foreign key relationship. So the primary key is going to be customer ID in our customer lookup table. And if you look at the data set, records 2 and 3 here for Frank, right? It's the same customer ID. If we look at the next, we have Joan, she's records 4, 5, and 6 here in the view, right? So we've got a lot of duplicate entries for each person, but we need this to be distinct, right? We need a distinct, unique list of people. So if we right click the column header and we select remove duplicates, this now creates a deduplicated list, let's sort ascending, of all of our customers. And we can verify that by going up to the View menu, clicking on our column profile tools, and we can look at the number of distinct and unique values. By default, Power Query always profiles the table based on the first 1,000 records. So this is a performance related thing. If you're working with a data set that has, hundreds of thousands or millions of rows or records, doesn't make sense to, to load all of that in all of the time. So what we can do is we can right click or click on this and update the profiling to be based on the entire data set. So this is a great way, to make sure that all of the records, in fact, are represented. So here you see we've got the same distinct and unique values here. Again, if you're new to Power Query, unique refers to the number of values that only occur one time in a column. Distinct refers to the total number of different values in a column. So when they equal the same, that means that this is a primary key, right? That's both unique and distinct. So that's a great, as you're going through and QAing data or, working through to profile it, for other projects, when you see columns where that distinct and unique value matches, that that's a primary key. Awesome. So that is our customer lookup. Next, let's go to the duplicate, and we're going to create our store lookup. Awesome. And for folks that are really following along here, you can probably guess what we're going to do here as well. All right, we need to come back over and we want to find our store ID. And we're going to select all of our store related columns. So over to store open date, we'll right click, remove other columns. We want to remove duplicates. And let's sort ascending again. Awesome. Right, so we've got 66 stores or 58 stores, but we go up to 66. If we look at the column profile details here, This always takes a moment to load. Again, we've got that same number of distinct and unique values. So again, indicating that primary key column. Awesome. So last thing, we have our products table. All right, so this is going to be products lookup. And same deal here. We're going to come over to our product ID. We'll scroll all the way over to product category. Again, we'll remove the other columns. And then we can come back. And on product ID, we'll remove duplicates. And again, the sort is not necessary. Just doing that to show you, right, the different product IDs here and how they're not, repeating for any one of these columns. Awesome. So that's actually pretty straightforward, right? We've duplicated that transactions table, that base, kind of merged table 3 times. We've created 3 different lookup tables, one for customer, one for store, one for product. So now, again, thinking back to that image that I was showing in the slides, what's the next step here that we need to take to the transactions table? If you think about it, we can now go in and we can remove all of these other columns that exist in these lookup tables, right? They don't need to exist as part of the transactions table anymore. So this is how we're removing some of that redundant duplicate data. So we want to keep all of our transaction related data the way it is for now. So transactions all the way up through customer ID. All right, so if we select our customer gender column and then come over to customer date of birth, can right click and we can remove these columns, right? We want to keep everything else for now and we just want to remove those columns. So we've got all of that transaction related data. We've got our customer ID. Next, we have our store ID. And that same idea. We want to take store country through our open date. And we're going to remove these columns as well. And then finally, for our product related columns, we can take our product name all the way through our product category column. And we want to remove these columns as well. Awesome, right? So because this is our fact table, right, we're removing all of those columns that exist in the lookup tables, and we're keeping our 3 ID columns, customer ID, store ID, and product ID, because these are our foreign keys within our fact table, right? And there's nothing else that we need to do to this table at the moment, right, because we're at the transaction level. Right, this is kind of the deepest level of granularity that you would get at for this data set. Awesome. So let's do this. We'll click apply. And so when we click apply, this is loading all of this data into Power BI's memory, right? It's creating, it's the start of that semantic model. And once this finishes loading, we'll hop over into the data model view and we'll check out the relationships. Awesome. You can see here in our data view, right, we got those tables loaded. And if we jump over into the data model view, you'll actually notice that this is a brand new workbook. I forgot to disable a feature called, it's basically, it automatically defines the relationships when you load them. Typically, I like to turn that off so I can define the one-to-many relationships the way that I want them to be defined. Power BI does a pretty good job guessing of what they should be most of the time, but just to kind of err on the side of caution, depending on how your naming conventions are, that kind of stuff, I like to manually define them myself. At any rate, let's take a look at what we've got. I'm going to kind of reorganize things a little bit. So we've got our store lookup. That store lookup, we have our store ID, On the one side, that's the primary key. It's connected to store ID in our fact table on the many side, right? So that's our foreign key. Same thing for customer lookup. We've got customer ID to customer ID. And then finally over here, we have products, right? And then same idea, product ID to product ID. So from a design standpoint, right, if we think, again, going back to the slides, this is that star schema, right? We have that central fact table surrounded by lookup tables. One of the things that I like to do when I'm designing my models is I like to place the lookup tables up top. Again, this helps me just visualize the way that filters flow between the tables. Again, a little bit outside the scope of kind of what we're talking about today, but as a best practice, I really like to design the models this way to visually understand, hey, this is where the relationships, this is the one, the many side, and then this is how the filters flow between the tables. Awesome. So this is our star schema, right? And this is, I had talked about this a little bit, but this is really, the best practice for many types of BI reporting, right? And again, you can have multiple fact tables, within your data model, but the idea here is that you're working with a bunch of one-to-many relationships, and this data model setup allows access to the exact same information, the exact same level of detail that you would get in that merged table, right? But instead of having it be, hundreds of thousands of records, right, we're able to shrink down the number of records and duplicate values contained within that transaction table. Awesome. So let's take this one step further. Right, I'm going to jump back to the slides here for a minute. And like we started to talk about, we've got some different hierarchies of normal forms, right? So that merged table is what's was in what that merged table is in something that's called first normal form. Other common forms are second normal form and third normal form. The whole idea here is that you're trying to improve the integrity of the data, reduce redundancy, and enhance consistency, right? So first normal form by definition, right, you're enforcing those atomic values, right? So there's no repeating groups or arrays in a single column. It's a single data point per cell, or per row. So the way that I would say this kind of like in plain speak is each row needs a primary key and each field contains a single value. Second normal form, this is where a table is already in first normal form, and it ensures that each non-key column is dependent on the primary key column with no partial dependencies, right? So the way to kind of think about this is that any column that's not the primary key, it needs to depend on the primary key. And then lastly, we have this third normal form. And these are tables that are already in second normal form, and they eliminate transitive dependencies. So all non-key columns, they don't depend on other non-key columns. And kind of a plain way to think about this is that every column that's not the primary key is dependent on only the primary key. And again, it's a little bit, kind of potentially funky or challenging to wrap your head around here. But we'll keep working through some examples to help illustrate it. Again, the idea here is that as you continue with these different hierarchies of normal forms, that you're really, again, you're trying to improve the quality and the integrity of the data. That said, normalization and going to like second and third normal forms, it may not be the best optimized, or the most optimized version of your data model. So let's jump back into Power BI and kind of think about this and look at what it looks like. So our transactions table right now is in first normal form. But in order to further normalize that into second normal form, we need to remove some of the partial dependencies, right? So what that means in practice here is that there are some columns that rely on part of the primary column. So something like transaction ID. So let's jump back to the transformation tab. And the issue in the transactions table is that we have columns like our order date, our delivery date, our customer ID, and our store ID that actually depend only on the order number, right? Not the line item. So the same information is repeated for each line item in the table. And if we think about it, this really makes sense since each order takes place on a specific date, and you wouldn't see individual customers purchasing different line items within an order, right? But on the other hand, we have columns like our quantity and our product ID that depend both on the order number and the line item. So meaning the full transaction ID, because orders can contain multiple individual products. So again, in order to achieve our second normal form of normalization here, we need to split this fact table into two tables, an order level table and an order line items table. So let's work through that process. So again, we can come back to our transactions table, and I want to duplicate. So first, let's create our order level table. Right, and for the order level table, we're going to start off with our order number, the order date, we want delivery date, our customer ID, and store ID. And we want to remove the other columns. Right? So we want to remove the other columns. The next step, similar to our lookup tables, is we want to remove the duplicates from the order number column. So we'll right click, remove duplicates. And now we have our order level table. We can come back to transactions. And to create our order line items table, order, right? We want to keep our transaction ID. We want to keep our order number as well, right? We need to make sure that we have a relationship between this and the order level table. We need to keep the line items, quantity, and we want to keep our product ID. So we'll remove the other columns, right? And in this case, we don't need to remove duplicates because transaction ID is already, I had mentioned this earlier, this is already at the deepest level of granularity. These are all unique, all distinct. So we don't need to remove duplicates as part of this table. Again, we've already updated the name for our table here. So we should be in a good spot. At this point, by splitting out the transactions table into these two new tables, we have achieved second normal form. So again, let's click apply. So one of the things that's interesting as we're going through this, started out with one table, right? We went through one round of kind of normalization, and we created 4 tables, or we created 3 new tables, but 4 in total. We now have 5 tables. So let's head back to the data model. And you can see now we have this, order level table here, right? It's kind of, I'll zoom out a little bit here. It's kind of interesting, right? Because it's on the many side between store lookup and customer lookup. It's the one side when it's related to the order line items table, right? And that's related through the order number, right? So there's one order in this order level table based on potentially there being multiple line items within an order, right? So by splitting these out, we've introduced, right, we've further normalized the data set, but now we've made our data model a little bit more complex, right? All of the relationships are still one-to-many, but we really don't have that single fact table, right, with all of those lookups. And then finally, products lookup is related to the order line items table by product ID. All right. So again, we're going through the different levels of normalization here. And, while this is, we have deduplicated, some of the data, I'd argue that this potentially makes this even, more challenging to potentially work with when you start thinking about creating DAX measures and visuals and all that kind of stuff. So we could stop here, but there's actually more normalization that we can do, right? Our product table, this is already in second normal form. So look at that table view for products, right? This is already in second normal form because all of our non-key columns depend on the full primary key, right? So there's no partial dependencies that we were seeing in the transactions table. But that said, we have this subcategory and category data, right? So there's a bunch of repeating values here, right? There's likely a lot that we can, kind of trim out or remove to further normalize this table. So let's take a look at what we can do in Power Query to take this table from second normal form to third normal form, and that's going to get rid of any of those transitive dependencies as well. So we'll head back. And here, we're going to be working with the products table. We're going to duplicate this 2 times. Right? And for those keeping score at home, we're up to 7 tables now. So that first products table, let's take a look at just our product subcategory. So let's name this subcategory lookup. And what we want to keep for our subcategory lookup is our subcategory ID, subcategory, and product category ID. And we want to keep this third column, this category ID column, because we need to relate this to the product category column within the data model. So we'll click Remove Other Columns. And then that same process here, right? We've got all of these, repeating subcategory IDs. If we remove duplicates, this is going to compress this table by a lot. Right? So now we've got these subcategory IDs, and we've only got 32 records within this whole lookup table. The last table you can look at here is going to be our categories lookup. Or we can keep the same category lookup. And here, we want to keep the category ID and the category name, right? Product category ID and the product category. So we'll remove our other columns again. And then you guessed it, we're going to remove duplicates. And now we've got a really nice streamlined product category table. So now we head back to products. Again, if you think about this in the same way we dealt with the initial transactions table, what can we remove from this products table now that we've created the subcategory and category lookup tables, right? If we scroll over, we can remove subcategory, category ID, and product category. we'll remove these 3 columns. Just want to make sure that I click the right thing, right? And now, by removing those columns, we've eliminated the redundancy within this table, and we've created tables that are now in third normal form. So again, we started with that one big merged table. We've created 7 new tables out of that and have really done a good job going through the different normalization hierarchies here. So apply. And we'll head back to the data model. And again, you see we have our other relationships defined here. So if you look at the design or the structure of this data model, this is becoming something that is more commonly known as a snowflake schema, right? So snowflake schemas are defined where you have, kind of like that branching, right? Almost like a snowflake would, that branching, chains of relationships, right? Depending on what you're trying to accomplish from a reporting standpoint, right? This is a very normalized, highly optimized model, but we really don't have that nice, friendly, intuitive star schema that we started with, right? We've got that snowflake schema here with chains of relationships between products and order line items. We have a couple of lookup tables that are connected to orders. And then, we have this random kind of relationship between our order level and our order line items table here. So the end state of this model is that while it is, heavily normalized, it's going to be much more challenging to understand and to potentially work with. So what's even, further here is you could keep going through this exercise, right? We could jump into our customer lookup table. Go back to customers. You could further, normalize this table as well, right? We've got a lot of different repeating, attributes for our customers here. So again, one of the big takeaways here is like, what's the right amount of normalization? Again, the general idea here is that star schemas are really the gold standard when you're creating Power BI models. But again, depending on what you are trying to accomplish with the data model, the types of data that you're working with, the best practices for your organization, there very well may be a mix between some sort of star schema and then having some other kind of denormalized tables. So let's jump back to the slides here. We'll kind of take things to the finish line. So key takeaways. Hopefully this is kind of coming through loud and clear. Don't use merged tables when possible. They make sense in some cases, but again, they promote redundant data, they decrease performance, and they promote errors. One thing that I will say is I really do love merged tables for a very quick analysis, right? If it's the easiest way to get data into Power BI, and you're not quite sure how to go through and break it out into a full data model, excuse me, it very realistically, it is the quickest way to open up Power BI, bring in a data set sometimes, and just perform an analysis. But again, at scale, don't use merge tables. Again, normalizing tables reduces redundancy and helps improve performance. So star schemas are very simple to build. They're easy to understand from a relationship and a filter flow standpoint. And again, it really is often the best model design to use within Power BI. Snowflake schemas, while they are more normalized, they often require more complex relationships and a steeper learning curve for end users. So again, when it starts or when it's time to create data visualization, creating DAX measures, any sort of calculations or filtering logic, when you get into Snowflake schemas, you really have to understand how the relationships are tied together to be able to diagnose why a certain measure is returning the value that it is. Again, we talked about this a little bit. balancing efficiency and complexity to find that sweet spot in your Power BI reporting. So while you can have models that have higher normal forms, right, they technically may be more optimized. But again, like that might not be the best place for you to live, if you will. And it can often make, reporting tasks, more complex or challenging. Again, kind of beating this point to death a little bit, but DAX calculations tend to become more and more challenging as the model grows in complexity. And then finally, practice building dimension tables in Power Query. If you haven't done this before, I hope that you saw by this, by this session that it really is easy. It's very simple to duplicate, a base query and then start using some of the Power Query tools to remove columns and, filter them the way that you need it to. So this is a great, very easy use case where, you can practice normalizing a table and building that kind of star schema data model. So I know we kind of cruised through a lot there, but at this point I'm going to stop sharing my screen and John, we can go back and dig into any sort of questions or comments that came up.
Yeah, this is great, Aaron. Thank you so much, and thanks for leaving some time. We've got a few questions that came up in the Q&A. Is freezing up a little bit. It's not okay. Perfect. There we go. It's just a little laggy. Awesome. So yeah, if folks are game, we'll put Aaron in the hot seat and see if he can answer your questions live. So this one's from Zhao. Wouldn't it be better to create references from the initial query to create the lookup tables instead of duplicating it? What do you think about that one, Aaron?
Oh, I'm so glad that this was asked, and I intentionally didn't bring it up, because this is one of the most common questions that we get. So when the difference between duplicating and referencing a query, duplicating, think about it as creating a copy based on the original data source. Referencing it, you're saying, hey, this transactions query lives here, always refer back to whatever that looks like, right? So when you start creating those other lookup tables against that transactions table, everything's going to work great. As soon as you go back to that original transactions table and delete the ancillary columns, the columns that aren't needed, everything that is referencing that is going to break.
Yep.
Right. So for this kind of work, duplicating the queries is really the best way to go.
Awesome.
Yeah.
Awesome. Yeah. Great question. I love that. That one got a ton of upvotes. So clearly people were looking for that answer too.
And that's another really easy thing to test, right? Like practice, that stuff in Power Query.
Mm-hmm.
Do the same work, create the tables, and create two sets of them. One where you're duplicating, one where you're referencing.
Yep.
And then delete the columns that you don't need in that original source, and you'll see those downstream referenced queries break.
Yeah, that's it's such a good example of it. This is a very related question too. How would the performance be affected if the initial merge table had millions of rows? Would duplicating the tables in Power Query cause performance issues? What do you think about that one?
Probably, yeah.
Yeah.
And it depends. Like, so I've worked on data sets where there's been, 100 million records, like we were connecting to like a SQL database, and there was, hundreds of millions of records in that table. And it becomes very, very slow, right? The performance is very slow. So again, filtering early is just generally like a best practice here. So if there's anything that you can do to filter that data set, if you knew that, hey, I've got this really big merged table, like what can you do ahead of time before bringing it into Power Query, right? Maybe there's a filter step that you can do, before you actually bring that table, into Power Query. If you had to bring it all in, what other filtering steps can you do early in your applied Power Query steps to make sure that you're not working with, all millions of those records for each of the duplicate queries?
Awesome.
The good thing is, like, once you have all of that data kind of filtered and you load that into the data model, Power BI doesn't really have to store all of those records in memory. It's just storing like the filtered sets of them.
Awesome.
Yeah.
Awesome. Yeah. Great explanation of that. Here's, this is an old friend that I haven't seen show up in one of these live in a long time. Aloha Tosin. In the real world settings, how does one actually get the transactions table? Like, where does that come from? Is it some database? And it seems the foreign keys are the real data. Are those foreign keys also auto generated at the source? So like, how does this actually all, right now it's like a fun reporting exercise, but like you're working for a business, how does it actually work in a business?
Yeah, so I think that there's some there's some very real parallels to some some database work that we're doing right now as a company, right? Where we have some, like, think about them as different levels of comfort with accessing data, right? So think about creating a 360 view of a customer, right? I want to know what an individual customer has purchased, when they did it, what store they did it at, and I need somebody that doesn't have a lot of like technical BI chops to be able to go in and say, yep, I need this field, this field, this field, but they need that complete picture. So that's a very real use case where you would have and make a strong kind of business case to have a merged table that gives you a complete picture of a user all in one table. Again, to the question here, like the foreign keys, they are the real data in the sense where that's what's tying it to another system, right? Whether it's the store related, like the point of sale related data, the actual product level data, right? And yeah, so again, like depending on where you're trying to report out on that, or sorry, for the auto generated, that's going to depend on the source, right?
Yeah.
A lot of this stuff is auto generated by the database or the developer, the engineer. They're going to say, hey, this is going to be a whatever the key is, the key type, and it's going to auto increment potentially based off of some starting value.
Yeah. So there'd be like, you'd never have somebody, hopefully, manually entering all this data, or at least certainly not for like a large data set like this. So take like Maven Analytics, somebody comes to our website and they want to take our courses, they sign up for a subscription. When they sign up, we use a platform called Stripe. We'd process a credit card payment to start a subscription. So then like think of those would be records in a table. That table would also have some other records that are foreign keys that would join to other tables about the individual person that is a subscriber. And all of that stuff, like Aaron was saying, it's kind of coded in automatically by an engineer, usually to say, okay, when a credit card gets processed, store this information in the credit card charges table and this other information in the people table, and link them based on a person ID. So you set up all that logic, and then it basically just happens at scale automatically. And that's just one example, but pretty much how you have to do it in a business. You can't be doing this stuff manually. So awesome. We've still got time for a few more. Another one from Zhao. Is the Snowflake schema potentially slower than having all the product categories and subcategories in a single lookup table?
Tough to answer that definitively with like a yes or no. There are tools. There are third-party tools that you could use to build two different versions of the model and test how performant it is. The way that I like to think about this is intuitively, what is going to make more sense to you, right? Like if we had left our products table as one single table, right? There was, 10,000 records or something like that, 18,000 records, in that total table. That's going to perform very, very quickly. That's going to be heavily performant, right, in Power BI. The added complexity of breaking out product categories, product subcategories, if the benefit of doing that helps you understand like filter flow and the way to create your DAX measures and to build visuals, that's more beneficial from your standpoint than it is thinking about the performance of it, right? So while it's, there might not be a big difference in the performance between the two, it might be easier for you to develop, in one scenario versus the other.
Yeah, awesome. Let's see what else we got. A few one more here. Are there general good practices for normalizing survey response data? Appreciate a reference article or a book. I wonder, I don't think we have any resources up on Maven. It's interesting. We probably should. Like, it's a pretty common use case. Gives me a good content idea that we should probably put together a guide for you. But yeah, Aaron, any thoughts there?
No, I'm trying to remember. I think either Chris Dutton or Enrique did a survey. There might be a video. Like, there might be something on our YouTube channel. About that. It's ringing a bell.
Maybe.
But unfortunately, off the top of my head, I'm not thinking of any, like, kind of good practices for survey response data.
Yeah, I'm just scanning real quick. I don't see it specifically, no, but
okay.
But yeah, I'm trying to think of just from working with surveys, myself. It's usually the data set that we're going to have will be, it's typically like a flat single table for the most part, right? And say you ask somebody 5 questions, each record in the table will be one person, one respondent to the survey, and then there'll be 5 columns for their questions, and the answers, or the values in the rows are going to be their answers. That's typically how I've set that up. I'm not sure what else I would tell you about that.
Again, like, being more general with a response, like thinking about like cleaning and normalizing the survey response data. Think about the outcome, right? Like John was saying, like, you conduct a survey and you want to know how Aaron Parry or John Pollard responded. How do you need to get that data structured in order to answer that style of a question, right? So if you do have data that's very messy, or there's multiple responses and different rows by person, like, how can you kind of group by an individual and create those columns? Sometimes there's pivoting and unpivoting that might need to happen there. So again, focus on the business question or the outcome that you're driving towards, and you can kind of figure out what you need to do to shape it and transform.
Yeah, awesome. And Eric, thank you. Eric says the great coffee survey. So yeah, there's definitely there's a good YouTube video up there. I think it's pretty high views. People really like that one. That's Chris doing the great coffee survey. So
that's right.
You can find that on our YouTube channel. Tons of good content there for free. I think we're actually going to cross 100,000 subscribers at some time this week, which is pretty cool. We're a smallish business, so it's fun to get to that milestone. So check that out. A lot of people have been enjoying it for free. And let's see, we're close to time, but let's see if we can get another one in here. That's good one from Donnelly. A lot of these concepts seem applicable to when designing a database with tables and columns in SQL. Are there conceptually any big differences when creating a data model using Power BI versus SQL? And Aaron's the perfect person to ask for on this, because he's one of the people that can go either way. So you're asking the right guy.
So it potentially, right? So in Power BI, right, again, like what you're after there is you want to make sure that the analysis in the DAX is easy, right? There's a common, saying where it's like, if the DAX is hard, the model is wrong, right? So what you're generally looking to create a well-formed, well-structured, star schema there. In SQL, and John, jump in here if I'm misspeaking, or you feel differently. But in SQL, generally speaking, like, you're going to have like unless it's like some bigger kind of like, a customer 360 table, or you're looking at a bunch of attributes per customer, you're going to have this table for this purpose, right? Where you're saying like, hey, we were talking about like striped subscriptions earlier, right? You're going to have a subscriptions table, right? You're going to have a table all about charges. You're going to have a customer table, right? You're going to have a table, for, whatever else it is. But, again, typically like the tables within SQL tend to be like very like, this is the singular kind of purpose of this table.
Yeah. Same thing. Think of like each table will contain sort of, could kind of think of it as like a log of items like people, credit card swipes, courses, things like that. So different types of objects, and they kind of just get logged in there. But kind of same idea. There's some tables that sort of serve as like a lookup table or a dimension table in the SQL databases that we would maintain too. So really, I think, I think the short of it is like a lot of these concepts really, really translate in both worlds. And then I think I love that Aaron touched on the point, like, even though Aaron's using Power BI a lot for reporting, he's also like trying to do as much upstream in SQL as possible to make it lighter and easier, so the DAX isn't complicated, and like getting your underlying table infrastructure right just makes everything so much easier. Yep. So yeah, awesome. Let's see. Let's go with one last one here because we're almost out of time. Thank you guys for all hanging with us. Thanks for a wonderful presentation, Aaron. Notice that most examples are on data modeling ETL using Power Query usually revolve around retail data. Could you please suggest resources for tutorials using Power Query in other domains?
Yeah, so it's beyond, if you haven't checked out the Maven Data Playground yet, that's a great resource, right? We do, Enrique and team do a lot of work to go out into the wild, if you will, and pull in and find kind of example data. But you're right, a lot of these examples do tend to revolve around retail data. It's a very tangible example or use case to use when you're talking about like sales and stores and customers and things like that. So, but also totally get that there's a lot of other use cases out there. There are, like Kaggle, I think that's .com, data.world is another one. Microsoft, actually, they put out some of their models for free. You can actually go and download like the SQL files and mess around with that. So things like all the AdventureWorks data, and they've got like the whole Contoso environment there where you can pull in different sections of the business from there. Honestly, try using ChatGPT or like an AI tool to generate a data set with a really good prompt. I've been doing that a little bit recently. I've got a whole demo that I'm going to work through for a forecasting, adding a forecast into a toy store data playground data set. At any rate, I use ChatGPT to help create that. So it's a great use case to create a data set if you can't find it.
Yeah, it's really kind of impressive. I remember like when I was making one of my courses with Chris, one of the first courses for Maven, I was counting my hours on everything, and I spent 40 hours making a data set because I wanted to have this rich trends, and I had to storyboard it and build it all in there. And like I have mixed feelings about seeing ChatGPT do it in 5 minutes. Like it's really cool. I'm like, man, I wish that was there. That was there 5 years ago. Yeah. But yeah, awesome stuff. So Aaron mentioned Kaggle, data.world, bunch of other places, the data playground. So people have posted some links in here. All those resources are free. So that's a really cool thing. ChatGPT you can use for free. So yeah, amazing stuff there. Thanks everybody for showing up. And Aaron, thanks a ton to you.
Awesome. Thanks so much, Sean. Thanks everybody.